Hello and welcome to this series Blast from Past by IMS. Here we discuss past year CAT questions in an area wise manner. Let's get started. So this is the first question. A confused bank teller transposed the rupees and paise when he cashed a check for Shelja, giving her rupees instead of paise and paise instead of rupees. After buying a toffee for 50 paise, Shelja noticed that she was left with exactly 3 times as much as the amount on the check. Which of the following is a valid statement about the check amount? So let us assume that the original check amount was X rupees and Y paisa, which is nothing but I can say 100x plus Y in terms of paisa, right? Instead of 100x plus Y, the teller transposed the rupees and paise and therefore he encashed 100Y plus X, and then he gave this amount to Shelja. Shelja takes this amount. She, buys a toffee for 50 paise. So this is what we need to subtract from it. And this is the remaining amount with her. And that is given as exactly 3 times the amount written on the check. So that is equal to 3 times 100x plus Y. So we got an equation here. Let's try to solve the equation. 100y minus 3y. So this is going to be 97y. And that's equal to 300x minus x plus 50, which is 299x plus 50. So y is going to be 299x plus 50 upon 97. Now, because y is paise and that needs to be an integer, so we can say that this entire quantity, that is 299x plus 50, should be divisible by 97. Now, certain part we can already see that is divisible by 97, and that is going to be 291x. Okay, so I'm going to separate that part. After separating 291x, I'm left with 8x plus 50 here. And let's divide them individually by 97. Now, we can say that this part is certainly divisible by 97, and that is going to give you 3x, right? So this is 3x, and the remaining part must be divisible by 97. So we can also say that this 8x plus 50 should be 97k, as it is divisible by 97. So let's write it over here. 8x plus 50 is equal to 97k. If I take k equal to 1 here, then this is going to be 97 minus 50, 47, which is an odd number not divisible by 8. So let's try taking k equal to 2. With k equal to 2, I'm going to get 97 to the, which is 194 here, minus 50. 50 comes from the other side, and this is 8x. So I'm getting 144 is equal to 8x, and that gives me x equal to 18. Now, this is a possible value for x, right? And if we substitute x equal to 18 here, we are going to get y equal to 3 into 18. And this value, look at this. This is 8x plus 50. We have taken it to be 97k as per this equation, right? So let's write 97k divided by 97, which gives us k over here. And we took k equal to 2, right? We took k equal to 2 over here. So that means this is 2. And therefore, this is going to be 56 paise, right? So this can be the amount which can be written on the check, which is 18 rupees and 56 paise. And based on that, we can choose our option 4. Now, there's one more value possible for k. Some of you might have this question. So let me clarify this. Because we have this linear equation with 2 variables here, that is 8x plus 50 equal to 97k. So we can say that k can take multiple values, and which is right. So the first value of k we are getting is equal to 2. The next value of k that we will get is after 8 values, because the coefficient of x is 8, right? So the next value of k is going to be 10. And for k equal to 10, my 8x is going to exceed 100. And not only that, y is going to exceed 100 as well. So that is not possible because y will be expressed in terms of paise. And that's why this is the only answer which is possible. The Veggie shop sells samosas in boxes of different sizes. The samosas are priced at rupees 2 per samosa up to 200 samosas. So this is the price given for this much quantity. And then it is given to us that for every additional 20 samosas, the price of the whole lot goes down by 10 paisa per samosa. What should be the maximum size of the box that would maximize the revenue? So we begin with this quantity given, which is 200. And this is the price, which is 2 rupees per samosa. This is price per unit. Okay. And the product of these two is going to be the revenue. Now, as per this instruction, it says that for every additional 20 samosas, the price of the whole lot goes down by 10 paisa per samosa. So let's say if I'm increasing this quantity by one lot of 20 samosas, which is 200 plus 20, in that case, the price per samosa will go down by 10 paisa. So the new price is going to be 2 minus 0.1 in terms of rupees, right? Now, similarly, if I'm, let's say, adding 2 lots of 20 samosa, so in that case, the new quantity is 200 plus 2 lots of 20 samosas. And in that case, the price will go down by 0.1 2 times. So the new price is going to be 2 minus 2 times 0.1. Now, similarly, let's say if I'm adding n lots of 20 samosas, then the price will also go down by 10 paisa n number of times. So for that case, we have 200 plus n lots of 20 samosas, and the price per samosa will be 2 minus n number of times 0.1, right? And we know that the product of these two quantities, that is number of samosa into price per samosa, is going to be the revenue for the shop, right? And we need to maximize this revenue. So let's try to maximize this product. The product is going to be 400 plus 40n minus 200 into 0.1n, which is nothing but 20n. And this is 20 into 0.1. So 2n square, which is negative. This is equal to revenue. So that's going to be minus 2n square plus 20n and plus 400. Now, how do you maximize this thing, right? So let's try to convert in form of a perfect square. I'm taking minus 2 common. So then this is going to be n square minus 10n, right? Now, what should be the last term for this to be a perfect square? According to, let's say, a minus b the whole square, a square minus 2ab plus b square. Similarly, can I say that this is n square minus 10n? So the last term has to be 25 to make it a perfect square. So what I've actually done here is minus 2 into 25. So currently 50 is what we have subtracted, right? Now, because we are subtracting 50 to balance, we need to add 50. And this 400 is already there in the question. So this is how I can rewrite the entire thing. Now, this is giving me 400 plus 50. So 450 minus 2 times n minus 5 the whole square, right? So this is my revenue expression. Now, if I want to maximize the revenue, right, in that case, I need to subtract the minimum possible quantity from 450, right? So what is the minimum possible quantity that I need to subtract? That should be 0, right? And for this to be 0, my n should be equal to 5, right? So I can say that when n equal to 5, the revenue gets maximized. And that is going to be 450 minus, see, if you put n equal to 5 here, the whole thing gets 0, right? So 450 minus 0, and therefore your revenue gets maximized at 450. But as per the question, we are not supposed to maximize the revenue. If you take a look at this, we have to find out the maximum size of the box when the revenue gets maximized, right? So if you look at this quantity here, this gives you the size of the box, which is 200 plus n into 20. Plugging in n equal to 5, I'll get the size of the box as 200 plus 5 into 20. And that is going to be 300. That's our option 2. If x, y, z are distinct positive real numbers, x square into y plus z plus y square into x plus z plus z square into x plus y upon x, y, z would be which of the following? So let's first simplify this expression, which is x square into y upon x, y, z. So if I divide it, I'm going to get x upon z plus x square z upon x square z. So here I'm going to get x upon y. Similarly, this is y upon z. This is y upon x. Then I have z upon y and z upon x. So I want to find out minimum possible value of this quantity, right? Because all the options are suggesting us that it is greater than 4 or greater than 5 or greater than 6. So we are in a way trying to find out the minimum value of this, right? Let's look at the property of AM and GM. We know that AM is greater than or equal to GM for any number of positive values, right? Now, when it is equal to GM and when it is greater than GM, right? So AM will be equal to GM in case if all numbers are equal, right? If all numbers are equal. Here we know that they are distinct numbers and therefore their ratios are also distinct, right? So here we strictly have a case of AM greater than GM, right? So what is the AM of these 6 values? AM is nothing but sum divided by the number of values. So we can say that my AM for these given numbers are x by z plus x by y plus y by z plus y by x plus z by y plus z by x. So these are 6 different numbers that have been given, and I'm taking their AM, so sum divided by 6. This should be strictly greater than, remember we have left the case where AM is equal to GM, so now we are looking into AM strictly greater than GM, right? What is the GM of these 6 values? 6th root of their product. So x by z into x by y into y by z into y by x into z by y into z by x. Now, over here, if you look at this, the entire thing gets cancelled out, isn't it? X gets cancelled. Similarly, y and z are also getting cancelled. So the value of this entire thing is 1, and the 6th root of 1 is also 1. So we have greater than sign and we have 1 over here. We can shift 6 from the other side. So 6 into 1 becomes a 6, and the left hand side remains as x by z plus x by y plus y by z plus y by x plus z by y plus z by x. So this is the answer. It has to be greater than 6. Now let us also look at alternative approach to solve the same question. So it says that for any positive number a, right? Let's say, for example, a is greater than 0, wherein a is any positive number. The sum of the number plus its reciprocal has a minimum value of 2. And that is why I can say that a plus 1 upon a is greater than or equal to 2, which can be understood as sum of any positive number and its reciprocal has a minimum value of 2. Very, very important property, right? Now, over here also we have 2 cases. It can be equal to 2, it can be greater than 2, right? So a plus 1 upon a will be equal to 2 only if a equal to 1 upon a. So basically both these values will be equal. But here we know that they are all distinct, right? So this case can again be ruled out. And that is why we are looking into a case where a plus 1 upon a is strictly greater than 2. What is a plus 1 upon a? It is nothing but sum of a positive number and its reciprocal, right? So here, can we say that, let's say this is a positive number, this is its reciprocal, they have a value which is greater than 2. Similarly, these two, that is the x by y and y by x, they also have a value which is greater than 2. And the third pair, y by z and z by y, they also have a value which is greater than 2. So greater than 2 plus greater than 2 plus greater than 2, the total value is going to be greater than 6. The next question says that two positive integers differ by 4 and sum of the reciprocals is 10 by 21, then one of the numbers is which one? So let's take two positive integers as x and x plus 4 as they differ by 4. Now sum of the reciprocals is 1 upon x plus 1 upon x plus 4, and that is given to us as 10 by 21. Let's try to solve this quadratic equation. So we have x plus 4 plus x upon x into x plus 4. This is equal to 10 by 21. Cross multiplication gives us 21 into 2, 42x plus 84 equals to 10x squared plus 40x. So 10x squared, 40 minus 42, it's going to be minus 2x minus 84 equals to 0. And I can divide by 5 throughout. So, 2 throughout, sorry. 5x squared minus x minus 42 equal to 0. So this is 42 into 5, that's 210. And that's nothing but 14 into 15. So we have a 5x squared minus 15x plus 14x minus 42 equals to 0. 5x common, x minus 3. 14 common, x minus 3. This is equal to 0. So 5x plus 14, x minus 3 equals to 0. So this gives us x equal to minus 14 by 5, which is not a positive integer. So let's discard it. And the other possible solution is x equal to 3, which is a positive integer. So if x is 3, the next number is x plus 4, which is going to be 7. So one of the number out of these two is 3 as per the option, right? So this is one way to solve the question. Alternatively, we can say that, let's say the positive integers are x and y only. Okay. So x and y are the integers. Their reciprocals are 1 upon x and 1 upon y. Now what is their summation? 1 upon x plus 1 upon y. And if we simplify that, it is going to be y plus x upon y into x, right? And that is given to us as 10 upon 21. If we just take a look at this thing, we will quickly understand that we want two numbers for which the summation is 10 and the product is 21, right? So when you say sum is 10 and product is 21, clearly those two numbers are 7 and 3. So this is how this question can be solved quickly without getting into quadratic equation. The function fx equal to modulus of x minus 2 plus modulus of 2.5 minus x plus modulus of 3.6 minus x, where x is a real number, attains a minimum at which of the following points? So let's first try to understand what is the meaning of this modulus of x minus 2. Modulus of x minus 2 is nothing but distance of x from 2. This is a simple meaning of modulus x minus 2. Same is the interpretation for modulus of 2.5 minus x, which represents the distance of x from 2.5. Now over here, we are looking to find out sum of these three distances. Can we say that? And that is why let's try to understand this with the help of a number line. So I'm going to plot these 3 points on the number line, which is 2, 2.5, and 3.6. So if I take my x anywhere on this number line, suppose let's take it over here. So I'm going to find out the summation of distances of x from these 3 points, isn't it? So distance of x from 2 is this, x to 2.5 is this, and x to 3.6 is this much distance, right? So this is one case. Let's try to shift x a little bit and see what happens. So right now, I'm going to take x somewhere between these 3 numbers. Suppose I take x over here. Now, once again, I'm going to find out the sum of distances of x from these 3 points, which is x to 2, x to 2.5, and x to 3.6. Now, you can clearly see that compared to the previous case, we have lesser total distance in this case, right? Let's try one more time. In this case, I'm going to take x as a middle value among the 3 numbers, which is 2.5 itself. So if I take my x over here, the distance of x from this point itself is 0, definitely. The distance of x from 2 is this much, and the distance of x from 3.6 is this much. Right? So if you compare these 3 cases, you will understand that you will get the summation of the distances as a minimum value when x is equal to 2.5. So this is the answer, right? Now let's try to understand and conclude something. So the total distance will be minimum, just in case if you have been given odd number of brackets, odd number of modulus rather. If you have odd number of modulus, like 3 modulus, 5 modulus, 7 modulus, we can always say that the summation of total distance will be minimum when x takes up the value which is exactly in the middle of all the points, right? It is not necessarily the midpoint of the extremes, right? But it is a value lying in the middle of, let's say, 3 points, or 5 points, or 7 points, right? What if x is an even number? Okay, so for odd numbers, it is a middle value. If let's say I'm having even number of modulus, right? In that case, x will take a range of 2 middle values, including both the middle values, right? So let's have a look at this question where we have total 4 modulus, that is even number of modulus, x minus 2, 2.5 minus x, 3.6 minus x, and x minus 100 all under the modulus, and we want to find out the minimum value of their summation. So let's plot these 4 points on the number line. 2, 2.5, 3.6, and 100. Now, if you want to minimize the summation of these 4 modulus, then we can say that the value of x can range anywhere from 2.5 to 3.6, both the values included. Okay, so from 2.5 to 3.6, you can take any value of x between these two, including the points, and that is where the function attains the minimum value, right? Now, this holds true for any even number of modulus. Let's say you have 4 modulus, maybe 6, 8, right? In any case, you have to find out 2 middle values, and x can range anywhere from the first one to the next middle value, right? And the summation of all the modulus will be minimum for that entire range of x. Let's look at the next question. Let gx equal to maximum of pi minus x and x plus 2. The smallest possible value of gx is which one? Let's try to understand this question with the help of a graph. So here we have a graph of x plus 2, and this is a graph of pi minus x. Out of these two, one is an increasing function, the other one is a decreasing function. And gx is going to be maximum out of these two function value at any given point. For example, if you take x equal to 0, so at this point, you are getting two function values. X plus 2 has a function value of 2, and 5 minus x will have a function value of 5. Which one is the maximum of these two? This is the maximum, and that is why this will be chosen as gx. Similarly, at x equal to 1, these are the two function values that we are having. And again, we are choosing the maximum of these two as our gx. Now, what happens at 1.5? At 1.5, both the function values are equal. You can see that. And therefore, because they both are equal, maximum also becomes the same. So this will be chosen as gx. What happens at x equal to 2? So one function has a value of 3 and the other one has a value of 4. Obviously, the higher one will be chosen as gx. And at x equal to 3, this is the function value of 5 minus x, and this is the function value of x plus 2. X plus 2 shows us a higher value, and therefore, this will be chosen as maximum. Now, if you look at these points that we have selected as gx, okay, these are the points we have selected as gx, right? The question says that, what is the smallest possible value of gx? So we have to check where this graph of gx is hitting its minimum value. It is hitting the minimum value at x equal to 1.5, okay, where the function value becomes 3.5. So 3.5 is the minimum function value, and therefore we can choose none of this as an option, right? So this is how we have solved the question graphically. Do we need to draw the graph in the exam? Not necessarily, right? So let's try to conclude what we have observed over here. We have observed that the minimum will be attained where both the function become equal, right? So can we simply equate both the values? That is, pi minus x is equal to x plus 2. So let's try to find out the value of x for this. We have 2x equal to 3, and therefore x equal to 1.5. So this gives us the value of x for which the function attains minimum. which was visible in the graph also. Look at this 1.5 over here, right? Now, when we put x equal to 1.5 in the expression for gx, that is gx equal to maximum of 5 minus x and x plus 2. If you put x equal to 1.5 here, you are going to get both these functions as 5 minus 1.5, 3.5, or you can say 1.5 plus 2, which is also 3.5, because they both are equal. So this is how we get the value of gx, by simply equating both the function values. Consider the sequence of numbers a1, a2, a3 to infinity, where a1 is equal to 81.33, a2 is equal to minus 19, and aj equal to aj minus 1 minus aj minus 2 for j greater than or equal to 3. What is the sum of first 6,002 terms of this sequence? So we have been given a1 equal to 81.33, a2 equal to minus 19. And then this thing is given, which says that aj is equal to aj minus 1 minus aj minus 2 for j greater than or equal to 3. So if I plug in the minimum value of j, which is 3, it gives me a3 equal to, now j minus 1 is 2 and j minus 2 is 1. So a3 is equal to a2 minus a1. What does it tell you? It simply tells you that any particular term of the sequence is equal to the difference of the previous two terms, isn't it? And that is why we can say that a3, which is the difference of two previous terms, that is minus 19 minus 81.33. So that's going to be minus 100.33. Same way, a4 is going to be the difference of two previous terms. So minus 100.33 minus minus 19, which is negative 81.33. Same way, a5 will be the difference of a4 and a3. So minus 81.33 minus 100.33, which gives us plus 19. a6 is going to be a5 minus a4, 19 minus minus 81.33. That gives us 100.3. a7 is difference of a6 and a5, 100.33 minus 19, which gives us 81.33. a8 is going to be 81.33 minus 100.33, and that is nothing but minus 19. Now, can you see that your a1, a2, a3, a4, a5, a6 are all distinct values? But then a7 onwards, we have started repeating the value in the same order, which means if you look at your value of a7, it is same as a1. Similarly, your a8 is same as a2. And therefore, I can also conclude further that a9 is going to be equal to a3 and a10 is going to be equal to a4. So we can say that there is a particular pattern or a cycle of 6 values which keep on repeating in the same manner, right? Cycle of 6 values that keeps on repeating in a same manner. What is the internal summation of a cycle? So if I want to find out summation of these 6 terms of a cycle, which is S6, how much is that? 81.33, 81.33 negative, they will cancel each other. Minus 19 plus 19, they will cancel each other. And minus 100.33 plus 100.33. So the net summation is 0, right? So I can say that sum of any 6 consecutive terms of this cycle is 0, right? Now, this is very important information for us because that helps us to get the summation of 6,002 terms. So I want to find out S of 6,002, right? Can we say that it is equal to summation of 6,000 terms plus the summation of next two terms? We have seen that summation of any 6 consecutive terms is 0. So summation of 6,000 terms is also 1,000 times the same cycle, right? And therefore, it is going to be 1,000 times 0, and that is equal to 0. So we are just supposed to add sum of term number 1 and 2, and that is going to be 81.33 minus 19. 81.33 minus 19 is 62.33, and that is our answer, which is option number 3. So let us try to derive some learning from this problem that we just discussed. We have seen that there was an expression given, that is a3 equal to a2 minus a1, and this had a cycle of 6 values, after which the values repeat. Okay. Similarly, if I say that I have A4 equal to A3 minus A2 plus A1, or maybe I have A5 equal to A4 minus A3 plus A2 minus A1. What is common in all these expressions? The alternate terms are positive, negative, positive, negative. Then here also positive, negative, positive, positive, negative, positive, negative. So if your alternate terms are positive, negative, and if you have, let's say, odd number of terms including both the side, left as well as right. Okay. In that case, the length of the cycle is 2n. If you have even number of terms in total, including the number of terms on left and right both, okay, which is equal to n, the length of the cycle will be n. Which means, let's say if I'm having 3 terms here, that is 1, 2, and 3. This is how we are supposed to count it, okay? Odd number of terms, including number of terms on both the side, left as well as right. So if you have 3 terms, the length of the cycle becomes 2n, which is 6. Now look at this case. You have 1, 2, 3, 4 terms, right? Even number of terms, the length of the cycle is same as n. So here I can say that we have a cycle of 4 values after which the cycle repeats. Over here, we have 5 terms, including the term on the left as well as right again, all right? So 5 terms, odd number of terms, length of the cycle will be 5 into 2, 10. Now, if you know this, you can directly derive that the length of the cycle in this previous problem was 6, and therefore, summation of 6,002 terms will be nothing but summation of term number 1 and 2. Now, whatever we have learned in the previous question, let's try to apply that in this question. It's very similar to that. Let gx be a function such that g of x plus 1 plus g of x minus 1 is equal to g of x for every real x. Then for what value of p is the relation g of x plus p is equal to gx necessarily true for every real x. So this question says that g of x plus 1 is equal to gx minus g of x minus 1. Isn't this very similar to A3 equal to A2 minus A1, isn't it? Look at this. Any particular term, that is g of x plus 1, is equal to the difference of 2 previous terms, which is gx and gx minus 1, right? So it's very similar to A3 equal to A2 minus A1, and therefore, we just learned that we have a cycle of 6 when you have 3 terms, putting together left and right. We have 3 terms. The alternate sign is positive, negative. Even that condition is satisfied, right? So the length of the cycle here is going to be 2n, which means 2 into 3. The length of the cycle is going to be 6. If the length of the cycle is 6, then after every 6 value, my function value is going to repeat, right? Now, what is the question asking you? G of x plus p is equal to gx, which means the function value will repeat for which 2 values, right? So g of x plus p is equal to gx. I can say that the function value repeats after an interval of 6, and therefore the value of p has to be 6, which is 4th option. The next question says that if the sum of first 11 terms of an arithmetic progression is equal to the sum of first 19 terms, what is the sum of the first 30 terms? So let's first try to solve this question in a conventional way, and then we'll discuss, some pattern. We'll derive some observation towards the end. So sum of first 11 terms, which is S11, is equal to S19. If I just plug in the formula here, right? S11 is what? 11 by 2 into 2a plus n minus 1 into d. So 11 minus 1, that is 10d. This is equal to S19, which is 19 by 2 into 2a plus 18d. This thing is equal. So let's try to solve further. 22a 110d is equal to 38a plus 19 into 18, which is 342d. 38 minus 22, so it's going to be 16a plus 342 minus 110, so that is 232b, and that's equal to 0. If I take 8 common from this, I'm going to get 2a plus 29d is equal to 0. Let's park it over here. Now we will find out the sum of first 30 terms, which is going to be S30. So S30 is going to be 30 by 2, 2a plus n minus 1, which is 29d. And we already have the value of 2a plus 29d, which is equal to 0. So this becomes 30 by 2 into 0, and that is 0. So this is our answer. Sum of the first 30 terms is going to be 0. Now let's try to look at the same question in a slightly different. So we have been given that sum of first 11 terms. What is that? T1 plus T2 plus T3 up till T11. This is the sum of first 11 terms. And that is equal to summation of first 19 terms. So that's equal to T1 plus T2 plus T3 up to T11 plus T12 plus T13 up to T19, right? Now, we can cancel T1 to T11 on both the sides. And therefore, we are left with 0 equal to T12 plus T13 plus T14 plus T15 plus T16 plus T17 plus T18 plus T19, right? So summation of these 8 terms is 0. And we also know that these 8 terms are in AP. So how come their summation can be 0 if they are in AP? Obviously, this term has to cancel this term. The first term cancels the last term. Similarly, the second term will cancel the second last term. Third term will cancel the third last term. Fourth term will cancel the fourth last term. Which means that all the terms on this side, on the left-hand side, will cancel all these terms on the right-hand side, right? So 4 terms on the left are going to cancel 4 terms on the right. Okay, maybe they will be positive, negative, like plus 3 minus 3 cancel, plus 1 minus 1 cancel, and so on, right? So yeah, the conclusion here is that 4 terms on your left side are cancelling out 4 terms on your right side. Okay, now how much further can we go on the left-hand side of T15? Definitely we can go up till T1, isn't it? So if you just go all the way up to T1, so we will be having T1 to T15. How many terms? 15 terms on the left side. Now to cancel these 15 terms on the left side, we need to have 15 terms on the right side. And that is where we have 15 terms from T16 onwards, which is going to be up till T30. So can we say that these 15 terms on the left are going to cancel these 15 terms on the right when they are getting added, right? So finally what happens is summation of these 30 terms is going to be 0. So this is another way we can look at the same problem. Now let's try to generalize. Wherever it is given to us that S of M, which means summation of first M terms, is equal to summation of first N terms, we can always take that S of M plus N is equal to 0. So if you know this property, you can straight away say that, okay, when S11 is equal to S19, that means S of 11 plus 19, that's S of 30, is always 0. The infinite sum of 1 plus 4 by 7 plus 9 by 7 square plus 16 by 7 cube plus 25 by 7 raised to 4 equals to which of the following option? So we can say that this summation is S, which is 1 plus 4 by 7, 9 by 7 square, 16 by 7 cube, and 25 by 7 raised to 4. Is this a geometric progression? Answer is no, right? So what we can do is, we can look at the denominators. They are following a constant ratio, right? It is not entirely a geometric progression, but the denominators like 7, 7 square, 7 cube, 7 raised to 4, they are observing a constant ratio. And what we can do is we can multiply by that 1 by 7 on both the sides. So I'm multiplying by 1 by 7 on the left side, which is S upon 7. I'm going to write another equation. So S upon 7 is equal to 1 upon 7 plus 4 upon 7 square plus 9 upon 7 cube, 16 upon 7 raised to 4, 25 upon 7 raised to 12, and so on. So I'm now going to, take a difference of 1 and 2, that is 1 minus 2. So all these terms will be taken negative. Left hand side is S minus S by 7, which is nothing but 6S upon 7. On the right side, see, we are going to take a difference in this manner. We are going to take a difference of the terms whose denominators are the same, right? So let's keep this 1 aside. And then I'm taking the difference of 4 by 7 minus 1 by 7, the terms with the same denominator. So that's going to be 3 by 7. Same way, difference of these two terms. I'm not essentially cancelling it out. I'm just taking the difference in this manner, okay? 9 by 7 square minus 4 by 7 square, this gives us 5 by 7 square. This is 7 by 7. And this is 9 by 7 raised to 4. This continues in the same manner. Have we now got a GB? Not yet. Okay. So maybe we can repeat the same process one more time and see what happens. So again, divide by 7 on both the sides. That is 6S upon 49 is equal to 1 by 7, 3 by 7 square, 5 by 7 cube, 7 by 7 raised to 4, 9 by 7 raised to 5, and so on. Now let us call it 3 and 4. Again, we are going to take a difference of 3 and 4, that is 3 minus 4. So what are we getting this time? Left hand side, 6S by 7 minus 6S by 49. So I need to take the LCM here, which is 6 7s are 42 minus 6. So it is 36S upon 40. Then on the right side, again, we are going to take the difference in the same manner, which is we are going to take a difference of the terms whose denominators are same, right? So this is the manner in which we will take the difference again. So we have to keep this 1 aside again. And then 3 by 7 minus 1 by 7 is going to be 2 by 7. Then you have 5 minus 3, which is 2 by 7 square. Then you have 7 minus 5, that's going to be 2 by 7 cube. And similarly, 9 minus 7 is also 2 upon 7 raised to 4. Okay. Is this a GB? Answer is yes. And because we are adding infinite number of terms, we can say this is infinite GB. So we can use that S infinite equal to A upon 1 minus R formula, right? Keep this 1 as it is. And over here, this is my S infinite, right? So using the formula, S infinite equal to A by 1 minus R, where A is the first term, obviously among these terms of S infinite, right? So this is going to be 2 by 7 as the first term upon 1 minus, what is the ratio of this infinite G? It is 1 by 7. So this is the value of 36S upon 49, which is what we have on the left side. Let's simplify this further. 1 plus 2 by 7 upon 1 minus 1 by 7, 6 by 7. 7, 7 cancel. So we have 1 plus 2 by 6, which is 1 plus 1 by 3, and hence 4 by 3. So what are we having now is 36S by 49 is equal to 4 by 3. If I cancel 4 here, I'm going to get S equal to 49 by 27, which is third option. So what we discussed previously was the conventional way to solve this question, right? But now I'm going to discuss a slightly different approach, which may be rather a raw way of doing the things, but that might be quicker. So let's see. I'm going to take percentage approximation for each term, which are mentioned over here. So 1, the percentage equivalent of that is 100. 4 by 7. Now we know 1 by 7 is 14.28 multiplied by 4 is roughly 57%. This is an approximation approach, by the way, right? 9 by 7 square, which is 9 by 49. Okay, so if we write 9 by 49, can we approximately take it as a 9 by 50, which is 18%. 16 upon 7 cube. So I'm going to write it this way, 16 upon 7 square into 1 upon 7. How much is 16 by 49? Approximate value of it is 16 by 50, which is 32%. And 32% I further need to divide by 7. So that's approximately 4.5%. What about 25 upon 7 raised to 4? So we can write it as 5 by 49 into 5 by 49. Okay, this is 25 upon 7 raised to 4. 5 by 49, approximately 5 by 50, and hence 1 by 10. This is also 1 by 10. So 1 by 100, and therefore approximately 1%. Right? Now we know that after this, we are going to get value which are very minimal and they are not going to contribute to the summation significantly. And that is why we can add up all these to get the approximate percentage equivalent. So 100 plus 57 plus 18, that's going to be 175 and another 5.5. So 180.5% roughly, right? Let us now check the options. So if you look at the first option, which is 27 by 14, which is very close to 200%, right? Let's have a look at that. 27 by 14. We can write it as 28 minus 1 upon 14. So it's 2 minus 1 by 14. That is 200 minus 1 by 14 is 7.14. So this is roughly 193%, and hence not the right answer. Next one is 21 upon 13. So it's going to be 1 plus 8 by 13, we can say, right? 1 is 100%. 8 into 1 by 13 is 7.69. We can round it up to 7.7%. And this is equal to 8 sevens are 56 plus another 5.5. So that's 61, right? 161.5%, which is again far from 180.5 that we have. So this is also not the right option. Look at third option here, 49 by 27. Now this can be written as 27 by 27, which is definitely 1. Plus we have another 22. So if we split this 22 as 18 first and then 4, okay. So 18 by 27 and another 4 by 27. This is 1. So that's 100%. Plus 18 by 27 is nothing but 2 by 3. That is 66.66%. And then you have 4 by 27. If we just take 4 by 28, which is 1 by 7, which is 14.28. So what is the approximate addition of all these? 100 plus 66, 166 and another 14, that is 180 and maybe another percentage. So that's 181%. This is the closest to what we have over here. And that is why option 3 is the correct option. So yeah, as I said, this is a slightly raw way of doing the things, but this helps us quickly approximate the things. And yes, you need to be really good at percentage and fraction equivalent if you want to try this approach. Let's have a look at the next question. Consider the set S equal to 1, 2, 3 up to 1000. How many arithmetic progressions can be formed from the elements of S that start with 1 and end with 1000 and have at least 3 elements? So we have to start with 1. We have to end at 1000. Okay, and we need to create arithmetic progression with 1 as the first term and 1000 as the last term. So what is the overall difference we have here? We'll call it an overall difference. That is equal to 1000 minus 1, which is 999. Now, the question is, using this overall difference of 999, will I be able to make an arithmetic progression with a common difference being 1? In other words, what we are asking here is that, can we equally split 999 in differences of 1? Yes, it is possible, right? We have 999 terms in between, wherein the difference for each term will be 1, right? So this is possible. Similarly, if I ask you, is it possible for us to create an arithmetic progression with a difference of 2, the common difference being 2? For example, this is 1, this is 1000, first and last term. The overall difference once again is 999. Now, is it possible for us to create an AP with a difference of 2? Obviously, it is not possible because the overall difference of 999 you will not be able to equally divide as differences of 2, right? So this AP with a common difference of 2 is not possible. Let's try with 3 now. 1000, first term, last term, right? And this is my overall difference. Is it possible to create an AP with a common difference of 3? Yes, we can say that 999 can be equally split as 3333, maybe 333 times, and therefore we will be able to put 333 terms in between, right? So what we are able to understand from this is that if 991 has 1 as its factor, then having an AP with a common difference of 1 is possible. 2 is not a factor, and that is why having an AP with a difference of 2 is not possible. 3 is a factor of 999, and therefore having an AP with a difference of 3 is also possible, right? So how many APs can be created? Can we simply look at the number of factors of 999? Okay, so let's try to find out the number of factors of 999. This can be written as 9 into 111, which is 3 square into 3 into 37. 111 is 3 times 37. So finally, we have the factorization as 3 cube into 37 raised to 1. Looking at this prime factorization, how do we get the number of factors? Number of factors is, obviously we know, power plus 1, isn't it? So this has 3 power, so 3 plus 1. And this has 1 power, so 1 plus 1. So 4 into 2, we have a total of 8 factors, which means there are total 8 different values which can be kept as a common difference, and therefore 8 different APs can be created, right? But now there is a small catch here which we need to understand. One of the factor of 999 is 999 itself, isn't it? So can we have an AP with a common difference being 999? If you do that, you begin with 1, your common difference is 999. So the last term is 1000. In this case, you only have 2 terms in the AP, and the question says that it should have at least 3 elements, right? So keeping this condition in mind, one of the factor, which is 999, should be discarded. You cannot have a common difference of 999. All the remaining factors can be possible as a common difference. So final answer has to be 8 minus 1, which is total 7 different APs can be formed, which is option number 4.